Hello everyone, here I am Dr. Bin Kumar going to give another important lecture on water potential and what are the different components of the water potential. So first of all, I will explain you what is the water potential. It is defined as the amount of work per unit quantity of the pure water that must have been done by the external force to transfer reversibly and isothermally an infinitesimal amount of the water from a standard state to the soil at the point under consideration. And you can also say as the water potential is the potential energy of water per unit volume related to pure water in reference condition. And in the other way, you can represent it as a Greek letter psi, and it is also represented as the potential equal to the force and that will be multiplied by the distance. So how you can quantify this? You can quantify this that it is the tendency of water to move from one place to the other place, and this movement will occur because of the shell or the external force, and that would be your solute potential, pressure potential, metric potential, and gravitational potential. In a nutshell, we can summarize it as a water potential is sum of solute potential, pressure potential, and metric potential, and gravitational potential. In the continuation, I will explain it to the osmotic potential. Suppose this is your pure water, and here will be having the maximum water potential, and this is your solute. When solute will dissolve in the pure water, there will be the lowering of the water potential of the pure water. So how it will happen? Because of this solute will detach the water molecules, and that divalent water molecules will bind positive ion to the negative ion, and this chlorine will bind to the hydrogen ions. So because of this, there will be the high gap between the two water molecules, and by this way there will be the lowering of water potential. So I will explain the osmotic potential through the example of the osmosis. Suppose here is the two condition. One is that here is the solution, here is the pure water, and this is separated by the semi-permeable membrane. You know, the semi-permeable membrane means solute cannot go, but only solvent can move. So when this will happen, automatically there will be the movement of the water from the high water potential to the lower water potential. So there will be the rise in the table up to some extent, and it will stop when the equilibrium in the term of potential will become equilibrium in both sides. So how I will determine that what is the water potential of this solution? So I will apply some external forces apart from that. So it is called your reverse osmosis, and when it will attain the same water table in the both sides, suppose here it taken 12 bar to stop up to this point, so the water potential will be of minus 12 bar of this solution. I hope you understand. So the next is your metric potential. Metric potential means capillary potential, and soil surface or other body that have the tendency of water to bind it by the force of addition force, and this is called your capillary potential. Because of this force, the water will rise in the soil. And another is your gravitational potential. Suppose your water soil is filled with the water, means all macro and macro pores are filled with the water. At this point, what will happen? There will be the maximum water potential, means near about the zero. So when the water supply start from the external sources, so after that there will be the downward movement because of the gravity, and it will happen up to the minus 0.3 bar, and this will take near about 48 hours to reach up to this bar. So this is called your field capacity, and in between that minus 0.3 bar to minus 1.5 bar, this is called your available zone, and this water is available for the plant. So that's why this is available water for the plant. But beyond the minus 1.5 bar, the water will not available to the plant, because water needs a very high energy to separate the water from this surface body. So this is your non-available water for the plant. Other is your pressure potential. Pressure potential means when the water will be inside the plant cell, the water itself will be in movement, and that will exert pressure outside. But because of the cell wall, there will be also the inside pressure, so water cannot go beyond that. By this way, the pressure potential always have positive value, but sometimes it will also have negative value when the concentration inside that will be very high. So at that time the cells will be shrink. So that's why only the pressure potential having the positive or sometimes negative value, and other potential always will be having the negative value. So what are the relevance or importance of the water potential? You can see here the movement of water from soil, plant and atmosphere happen because of this gradient in water potential. You can see here is that the soil is having highest water potential, then root, then it is followed by your xylem vessels, then leaf vessels and the atmosphere. Because of this gradient in the system, the movement of the water occur from soil to the plant in atmosphere. So it is very important to maintain the soil plant atmospheric continuum. The water potential gradient is very important. I hope you understand. If you understand, you can subscribe me for more information at my YouTube channel Dr. Bipin Kumar. You can also like my Facebook page Dr. Bipin Kumar. You can follow me on my Twitter at @agrobipinIRI.